Okay, so let's start taking a look at this stuff. So like Crew was saying before, a lot of this is going to be review for you guys, hopefully, right? Because we've dealt with lines and we've dealt with like slope of lines and y-intercept and that kind of thing, right? So hopefully it's mostly a review with this stuff. So first thing there, linear function. Linear sounds like line, so basically these are all going to be graphs of straight lines, okay? How we see the equation sometimes for slope of straight lines is in that slope-intercept form. So just a reminder of what that looks like. Y is like your y coordinate. That m stands for our slope. The x is just our x coordinate, and then that b stands for our y-intercept. Okay. So that's one way of looking at equations of lines is with our slope and y-intercept. And then slope, like we had last chapter, slope is also listed as rate of change sometimes. Usually it's rate of change when it's like on a curved graph versus a straight graph. Usually on straight graphs they call it slope, but they can also call it rate of change. They mean the same thing. And it's the same formula, y minus y over x minus x we've used before. Next couple things there are x-intercept and our y-intercept. So our y-intercept is where it's going to cross the y-axis. That's always your initial condition or your starting point where you're kind of building off of. And then your x-intercept is where it crosses the x-axis. So I'm just going to do a little sketch of that so you got one. So like if that's your graph there, and you've got a line kind of going like that. Say maybe this one's crossing at 1, 2, 3, 4. Maybe we'll make that 5. And 1, 2, 3. We'll make that one 4. So here, that point would be our x-intercept. With our x-intercept points, the y value is always 0. So I would put like y is always 0. And you can see that there because what we went 1, 2, 3, 4, 5 spaces over. So that would be right 5, up 0 to be right on the line. So that ordered pair would be 5, 0. But your y value is always 0 in the x-intercept case. Opposite thing happens then for our y-intercept, which is the one where it crosses the y-axis. So that's our y-intercept. In those cases, our x value is always 0. And then like that ordered pair, I think it went up 4, 1, 2, 3, 4, yeah. So that would be over 0, because we didn't go at all right or left, and up 4. So again, those x values will always be 0. So if they say, hey, find the x and y intercept, you can just plug in zeros for the opposite letter, and then it'll kick out what number is your x and y intercept if we need that. I think we do that more when we do the graphing stuff. Okay. And then if they're talking about like constant increase and decrease, that's just dealing with like the slope. So if it's a constant increase, that would just mean it's a positive slope going uphill. If it's a constant decrease, it'd be a negative slope. And then kind of similar to what we've talked about before, it would be positive if as our x increases, our y also increases, so going uphill. Constant decrease is as our x increases, our y decreases, so it'd be going downhill. And that'll kind of come in with these next couple things here as well. So when you draw these graphs, I wouldn't do full-blown like graphing out those like too crazy. I just do like a sketch like that and just do something like that. I wouldn't make it like too fancy or anything, just so you kind of, the more important ones you probably know, positive and negative, but you might get confused sometimes on the 0 and the undefined. So I would make sure you got those ones down. Not going to hurt to have the positive and negative just in case your brain blanks on the test, but like I said, I would just do a simple sketch of it. I wouldn't do like the full-blown graphs. But get that jotted down and then we'll talk through that stuff quick. And that theorem is on page 154.
Attention, students that are supposed to be going on the field trip with Miss Lynch, you need to report to the hallway outside of the office immediately.
Okay, so let's just kind of talk through this stuff. So that parallel lines and slopes theorem, that should be the same theorem that we had back in geometry. So it says parallel lines and slope theorem. So two non-vertical lines are parallel if and only if they have the same slope. So we know parallel lines are basically, that's Penstein there, basically lines that go in kind of the same direction there and don't ever cross each other. What this is saying is just whatever the slope of one of them is. So like say that one's like rising 1 and running 2. The other parallel line would be the same thing, rising 1 and running 2. They always have the same slope if they're parallel. The reason they say two non-vertical lines there, what's the slope of our what's the slope of our vertical line? Undefined. So can that be like when they're doing that, because it's undefined, that's not really a slope, so that's why they say non-vertical. Okay. Anyways, so next couple things there. Again, the positive and negative slope is probably familiar to you guys, right? So like, you know, if you're going uphill, that's positive slope. Downhill, going to negative slope. And then it just says like your m value or slope is greater than 0, m value is less than 0. The setup for those equations is always going to have your slope and your y-intercept with a y and an x in both of those. The different equations, and again, we talked about this some in geometry and hopefully talked about it in algebra as well, the kind of different style ones is when it's like a horizontal line like this. If it's a horizontal line like that, the slope is always 0 on that. And then our equation for that line is just going to be y is equal to, and then just a number, and it's always the number that it goes through on the y-axis, okay? And that's because every single y value on that line is exactly the same. Opposite is true then with the undefined one. So the undefined one is the one that's straight up and down like that. That is always going to be x is equal to a number, so you're not even going to have a y in your problem at all, just x is equal to a number. And again, it's always the value that it cuts through on that x, so like I think it's like 4 or something in that case, but it's always just going to be x is equal to that number. Okay, I think the rest is in your example packets then, so grab those that I gave you guys today, and we'll start walking through those. So now what they're going to ask us to do is basically kind of set up some equations from story problems based on like slope and y-intercept. So here we got Claire sells sports cars. She gets a base salary of $30,000 a year plus 2% of her sales. If Claire's sales for the year total D dollars, what will her salary S be for the year? Okay, so let's start with like what our total amount's going to be. What do you think the total's going to be? Do you think it's going to be like the dollars that she's making in sales or her salary? Probably the salary is what we're looking for the total, right? So whatever the total is, I start with that value. Okay, so now we got to think of our things that combine together to make that salary. We got her base pay there of that $30,000 and then 2% of her sales. Okay, so which of those do you think would be the slope and which one would be the y-intercept? So the 2% is going to be the slope because that's how much she's gaining, which then would mean that 30,000 is our y-intercept, right? So what I would do, I would put like, so if we're 2% here, how do we turn 2% to a decimal? Yep, so we divide it by 100, so it'd basically be like 2 divided by 100, which would be 0.02. So that's what we're going to use for our percentage in our equation. 0.02. That would be like our slope or like our rate of change, how much it's changing each sale she makes or whatever, and then that is going to be times our dollar amount, right? Because that's how much she's getting off of each of those sales. And then plus, originally she's going to get $30,000 no matter if she sells a car or not. So that would be our y-intercept, okay? And the y-intercept is always like our starting amount. So whatever we're starting with, and maybe you want to write that as a reminder, starting amount, whatever your starting amount is, or like your initial amount, that's always your y-intercept, and then whatever's changing is your slope. And I think that's all they want us to do on that one, is just come up with the equation. Okay, so next one here, similar situation, come up with an equation. So a pool contains 85 gallons of water. Suppose a hose adds water to the pool at a rate of 7 gallons per minute. Write an equation for a function representing the amount of water in the pool t minutes after the hose is turned on. Okay, so this one wants us to write an equation for a function. So function notation, do you guys remember that? Where it's like, so it's a pool here, so I'm just going to go P of our value here that they give us for that variable's T. Do you guys remember function notation? Yeah, so the P doesn't really mean anything. That's just kind of like what our Y would be. And then the T just tells us what our X value is, basically. Okay, so again, we got to think of what would be our slope and what would be our y-intercept. What do we think here? Yes, our 85 would be our B because that's our starting amount, right? So we're starting with 85 gallons of water in that pool. So we're going to start with the 85. And then that 7 gallons per minute would be how much we're changing for every minute that the hose is running, right? So that would be 7, and then our variable here that they want us to use for minutes is T. So it'd be like 7T, so 7 times our number of minutes, plus the 85 gallons that was already in the pool. Okay, again, that one's just a setup. We don't have to do anything else with it. All right, next one here. Rick gets an allowance of $15 per week. Whenever his parents pick up a dirty dish he's left behind, he loses 30 cents of that allowance. Write an equation to model this situation. Okay, so they don't give us any letters here. You just want to go A for allowance and D for dishes? Something like that? Okay, so A for allowance, that'd be like our total amount, right? What our goal is to get to is the total allowance. Then we got to think about our slope and y-intercept. So what do we think which would be slope and which is y-intercept? Oh. Yep, so I always start with the starting amount. So we're starting with $15 a week, which is crazy. Do you guys get allowance? Yeah, I never got an allowance either. It was do what I tell you and be quiet about it. You get no money. Your allowance is living here. That's usually what I was told. So yeah, so that $15 a week is what we're starting at. And then every time he messes up and leaves a dish out, he loses 30 cents. What happens when he's losing 30 cents? It's going to be subtracting or going down. Since I wrote it this way instead of subtract, I'm going to make it negative. So he's losing 30 cents, so negative 0.30. Yep, for each dish he leaves out. So that's one way to write it as like the negative there, or like Krill said, you could also do this as subtract. So if you wrote it another way here, it would be like 15 as our total minus 30 cents per dish. That would also be a fine setup there. It doesn't matter which way you go. Either way is cool with me. Okay, so then if we need to graph that here, we know that our y-intercept is going to be 15, right? So we got to at least go up to 15 here. And does 15 need to be near the bottom of our graph or the top of our graph if our values are going down for the slope? It needs to be near the top of the graph, right? Any ideas what you want to count by there? Twos. You want to count by twos? Okay, so if we go 2, 4, 6, 8, 10, 12, 14, 16. Okay, and that would be up the side, those are our allowance numbers, right? So that'd be like our dollar amount, and you could label that as allowance for A. And then across the bottom, that would be our dishes. So number of dishes left out. And there, it's probably going to take us quite a bit of time here to get all the way down to 0 because we're only losing 30 cents a dish. So if I just count by ones there, I'm not going to get like very far across. I won't get all the way out to my like x-intercept where it crosses. I'm actually going to count by tens here. And I probably could have counted by something a little bit bigger than that because it ends up crossing at 50. If you weren't sure, like if you didn't have me just to tell you where it crosses, a couple things you could do. You could also take this equation and put it on your calculator and graph it to kind of see where it would end up crossing. You could also plug in since this is the x-intercept, you could plug in a 0 for the a value. So like 0 is equal to 15 minus 0.3 times d. And then you could solve that out for d to tell you where it's going to cross that line. That's another way you could go about that. Or you could just kind of eyeball it and hope for the best. Either way would be fine. Okay, so here, like I said, we're starting at that 15. So that would be our y-intercept. So kind of just between our 14 and our 16. And then now it gets a little bit messy because we're dropping by 30 cents for every dish. So here, is it going to be easy for us to count by like 30 cents is going down there? Probably not. So I might actually just revert to my calculator here. And just go to my y equals and type this in so I can get a table. So like if I go to my y equals, and I could type either of those equations. So like if I go like 15 minus 0.3 x and graph it, you're probably not going to see anything on your initial screen because like we talked about, our y-intercept is up at 15, and then like I said, it has to go up to 50. So you could zoom out if you wanted to see, oops, too far. You could zoom out if you wanted to see like your actual line there. You can kind of see it a little bit better there. But really, we just need the stuff from the table. So I'm just going to go to the table, and then I'm just going to get some values from here. So I'm probably just going to try to keep it kind of simple here, and since this was counting by tens, I think I'm just going to do my multiples of tens for my points I come up with. So if I just go to like 10, that was 10, 12. So if I go here 10, 12, that was something on my table. Kind of follow me so far why I did that. Just pull it from the table. And then if I go up to 20, that would be 29. 30 is 6. And then 40 is 3. And then 50, like I said, I believe is 0. Yeah, 50 is 0. So that'd be kind of our setup there. So that'd be our graph of that. Now realistically, and we're going to talk about this tomorrow a little bit more, could this be a continuous line where it has a line all the way through that? So you can have decimals of dishes? Nope. No. So realistically, it shouldn't have a line there. It should probably be a bunch of dots. We'll talk more about that in the next lesson, so don't get too wound up about that now, but we'll talk more about discrete and continuous when we're graphing. But realistically, it should be a bunch of dots all the way across there instead of a line, and maybe you could write that like dots because it's discrete. But like I said, we're going to talk more about that tomorrow, so don't get too wound up about that. Okay, and then last one there, it says if Rick received no allowance last week, how many dirty dishes did his parents pick up? So what do you think? So if he got no money, how many dishes did they pick up? 50, which if you've got 50 dirty dishes out, for God's sakes, that's ridiculous. You would be kicked to the curb. So that would be 50. And like I said, if you didn't have the graph and you weren't sure, so say you graphed it a little bit different, what you can do is, like I was talking about before, you can plug in that 0 there for your allowance value is equal to like your 15 minus your 30 cents per dish. And then you can solve that out. So like if I was solving for D there, I'd subtract 15 from each side. So 0 minus 15 would be negative 15 is equal to negative 0.30D. And then that would be multiply, so to get rid of multiply, I would divide by that, negative 30 cents on each side. And then if you do negative 15 divided by negative 0.3, you do get that 50 value. So that would be the same thing. So like I said, you can kind of pull that from the graph, because obviously we graphed it out in that way, but say you counted by something different and your graph didn't quite hit that, you can also plug in there and get that. Okay? All right, so that's it. So book page assignment there, 154, 1 to 20, skip number 14.